Today we're going to take a look at complex numbers dealing with different operations. So we are to perform the operation, simplify, and write the answer in standard form. And if we remember from last class, standard form is A plus BI form. So the first one, we have multiplication. So we're going to multiply 8 times 3, then I times I. 8 times 3 is 24. I times I is I squared. We know I squared is equivalent to -1. So we're going to replace I squared with -1. So we've got 24 times -1, which is -24. For number 2, we have a square root that is squared. When we have that, these are called inverses. We will get more into that later in the year, but essentially they cancel each other out. So we are left with -3. You can also look at it by writing your square root of -3 twice. Since they are same on the inside, you keep what's on the inside. For number 3, you have -2i cubed squared. So we're going to write that twice. We know I cubed is equivalent to -I. So we're going to go ahead and replace I cubed with -I. So we have -2 times -I. Keep your other -2 times -I. We go ahead and do our multiplication. -2 times -2 gives us a +4. -I times a -I is a positive I squared. But we don't want to leave our answer because we have that I squared. So I squared is equivalent to -1. So we're going to use substitution. So 4 times -1 to produce a -4. For number 4, we have 2i on the outside. We're going to go ahead and distribute. So we have 2i times -5 is a -10i. 2i times a -I is -2i squared. To get it in standard form, we don't want that I squared. So I squared is equal to -1. We're going to go ahead and replace that. So we've got -10i minus 2. We're going to replace your I squared with a -1. So we have -10i. -2 times a -1 is a +2. And in standard form, remember, is A plus BI. So we need to go ahead and switch those around. So we will have a 2 minus 10i for our final answer. For number 5, we need to look at what operation we're going to do, and that's addition. So we're going to go ahead and add these. Just like you would with x's, you're going to combine your like terms. So we have a -7 and a +12. Then we have a -5i and a -2i. So -7 plus 12 is 5. -5i minus 2i is -7i. For number 6, we have a subtraction. We are going to keep, change, change. What I mean by that is keep your first, change to a plus, change all your signs after. So now we've created an addition. So we have 10 plus 24, -I plus 9i. So we have 34 plus 8i. For number 7, the operation between here is multiplication. So you're going to multiply or FOIL. 3 times 4 is 12. 3 times negative 3i is negative 9i. 2i times 4 is a positive 8i. 2i times a negative 3i is negative 6. I times I, remember, is I squared. We're going to go ahead and combine our like terms. So we have 12 minus I, or minus 1i. We also have this I squared, which we know is equal to negative 1. So we've got minus 6 times, we're going to replace that with a negative 1. So we have 12 minus I plus 6. And combining our like terms, we have 18 minus I. For number 8, again, we have multiplication, so we're going to multiply. 5 times 5 is 25, plus 10i, minus 10i. Negative 2i times a positive 2i is going to be a negative 4i squared. We have like terms here. And we also know I squared is equal to negative 1. So we will have 25. Our like terms, positive 10i, negative 10i, become a 0, so they go away. Minus 4 times a negative 1. So 25 plus 4 gives us 29. What is the difference about answer 8? Well, compared to question 7 and question 8, your I went away. Since your I went away, if it was in standard form, your imaginary part equals 0. If we take a look at 8, your 5 minus 2i and 5 plus 2i, what do you notice? Hopefully you realize that there is a plus and a minus. Those are called complex conjugates. And when multiplied, they will produce a real number. We're going to use complex conjugates for number 9. This is a division problem, and our goal is to make the bottom, or denominator, a real number. So we're going to multiply by the complex conjugate. So taking a look at number 9, you have a plus there, 1 plus 3i. So the conjugate's going to be a 1 minus 3i. It's the opposite sign. So we're going to multiply the numerator and denominator by 1 minus 3i. It may help to put parentheses. So let's go ahead and multiply our numerator. 2 times 1 is 2. 2 times negative 3i is negative 6i. Then we're going to go ahead and FOIL our denominator. So 1 times 1 is 1. 1 times negative 3i is negative 3i. 3i times 1 is a positive 3i. Positive 3i times a negative 3i is a negative 9i squared. If we take a look at our numerator, there's nothing we can do, so let's look at our denominator. So our numerator stays the same as 2 minus 6i. We want to try to combine like terms. A negative 3i plus 3i is going to become 0. We know I squared, again, is equal to negative 1. So we've got 1 minus 9, and I'm going to replace that I squared with a negative 1. So 1 minus 9 times the negative 1 becomes 1 plus 9. So I've got 2 minus 6i all over 10. But are we done? Always see if we can reduce. So is there anything that we can take out of all of those numbers? How about a 2? So we'll have 1 minus 3i over 5. You could also see your answer as 1 over 5 minus 3i over 5. Either answer is accepted. Let's try another division. So we've got to determine the complex conjugate to 5 minus 2i. Since we have a minus, our complex conjugate is going to be 5 plus 2i. So that's what we're going to multiply, numerator and denominator. 5 plus 2i over 5 plus 2i. Put parentheses. We're going to go ahead and distribute your negative 6. So we have negative 30 minus 12i over, and we have to FOIL our denominator. 5 times 5, 5 times 2i, negative 2i times 5, and a negative 2i times a positive 2i is a negative 4i squared. We cannot simplify our numerator at all, so we'll leave it as negative 30 minus 12i. Taking a look at our denominator, combining like terms, a positive 10i minus 10i becomes 0. We know I squared is equal to negative 1. So we will have 25 minus 4, replacing our I squared with a negative 1. This becomes a positive 4. So we will have negative 30 minus 12i over 29. Can we reduce? No, so we are done. For number 11, again, figure out the complex conjugate. You have a plus here, so it'll be a 5 minus 2i. So we're going to multiply numerator and denominator by 5 minus 2i over 5 minus 2i. Put parentheses. And yes, we need to FOIL or double distribute the numerator and the denominator. 2 times 5 is 10. 2 times negative 2i, negative 4i. I times 5 is a positive 5i. I times a negative 2i is negative 2i squared. All over, double distribute or FOIL your denominator. 5 times 5 is 25. Negative 10i. Positive 10i. And negative 4i squared. And now we have to simplify. Taking a look at our numerator, combine our like terms. So we have 10 plus I, or 1i. We also know that I squared is equivalent to negative 1. So we're going to go ahead and replace that. So we have minus 2 times negative 1. All over, combine like terms, those cancel. Our I squared again, we're going to replace with a negative 1. So 25 minus 4 times a negative 1. We can go ahead and clean this up a little bit. Our negative 2 times negative 1 becomes a plus 2. Our negative 4 times a negative 1 becomes a plus 4. So we've got a 10 plus a 2 gives us 12 plus I over 29. And again, you could write your answer as 12 over 29 plus I over 29. So either answer we will accept.